Welcome everyone, and thanks for sharing this part of your day. The focus of this presentation is on using the GeoWeb 3D confinement system and installation best practices. This presentation assumes you're already familiar with GeoWeb geocells and their integral components. So it's going to bypass some of that basic background information and focus on next level and intermediate techniques. Please see our on-demand resources available at prestogeo.com for a deeper understanding in any one of the applications covered today, and follow up with our team, info@prestogeo.com, with any questions. Thank you. I'm Jose Pablo, or JP, the business manager with Presto Geosystems. We manufacture industry-leading erosion control, stormwater management, and porous pavement products, all made in the upper Midwest of the United States. Through an extensive national and international distribution network, we offer technical and site support, as well as free project evaluation from our in-house design engineering team. Today's presentation will help you leverage our over 40 years of geocell experience and get installation best practices and technique tips. Here are the things I hope you get out of today's presentation. Understand the benefits of using a soil stabilization system for the major applications of load support, slope protection, channel armoring, and earth retention, with some fundamental installation steps for each. Gain install technique tips to make installations more effective and efficient, and how to train your team to set them up for success and ensure the best project outcome. During the presentation, if you have any questions, please type them in the chat window and I'll answer them after the presentation. Presto worked with the U.S. Army Corps of Engineers to develop geocell technology in the late 1970s, and we've been innovating ever since. Our products have been used in nearly 200 countries and in every state of the U.S. We go beyond simply providing a product, all with an eye towards providing a complete solution for your project. We're going to start out with a quick recap of the GeoWeb 3D soil stabilization components, and then we'll get into technique tips for installing each of the major application types. The primary elements of any geocell system, cell walls, internal junctions, and connectors, must perform uniformly as a complete system. We stand behind our numbers so you can deliver certainty in the solution and build with quality materials you can trust. GeoWeb and our accessories are made in the USA under strict quality assurance and environmental control processes, sure to comply with all requirements for Build America, Buy America, and the Infrastructure Investment and Job Acts. The system components are all the supporting pieces that help the GeoWeb protect the surface and subbase layers, and also ensure relatively uniform performance of that interconnected system, thereby protecting against the damaging effects of non-uniform deformation and differential settlement in response to applied loads. Presto's GeoWeb system components increase strength and speed of installation, each of them offering some additional best practice options that we'll mention in context with installation examples. Let's begin with installation techniques for the GeoWeb load support system. The first pro tip is to use a quality engineered solution best suited to your project needs. Uniform and consistent, proven performance and durability, especially in demanding site environs, will be well worth it in the long term. And our in-house design team can help you choose the right geocell size based on site conditions. Soft subgrades, like the harbor wetlands seen here, are where GeoWeb geocells shine. So here's a quick overview of the installation process. And you start by getting the subgrade ready, then geotextiles or other planar geosynthetics as required by design. Next, lay out the GeoWeb sections. The GeoWeb sections are then interconnected. And the AtraKey connector is shipped in convenient to hold 3 packs per case, as you see in the photo on the left. This mini pack can be carried to where connections are made, a good technique tip. A pro tip is to use contractor pouches or aprons for a hands-free way to hold and carry these keys and make the fast connections even speedier, as you see in the 2 photos on the right. The specific engineering values of the AtraKey will ensure the system holds up to loading over time without the corrosion seen in staples, the failure of underperforming cable tie systems, or any cumbersome multi-piece connectors. You'll want to hold the GeoWeb sections open for infilling, either with temporary stakes or by filling a few cells around the perimeter. We'll see an example of that in just a few more slides. Infill is placed, spread, and compacted with an appropriate wear surface. According to design, that could be an unpaved surface, a flexible pavement, or a rigid pavement atop the GeoWeb. Let's look at some examples from an unpaved load support system first. An aggregate surface has advantages in saving pavement costs, and with the GeoWeb system filled with open graded base course, you can design a system that allows stormwater infiltration and provides stormwater storage. This was a project for a sawmill in Canada. Spring snowmelt and fall rains cause flooding and soft, challenging ground conditions in the infeed area. And this photo is great to see how the GeoWeb was placed. Held open with stakes at the perimeter, and then the infill was spread. Presto worked with the owners to develop a design to manage stormwater and snowmelt while providing stabilization and support of the heavy loads over soft subgrades. A 6-inch or 15-centimeter GeoWeb load support system with high-strength woven geotextiles was installed with infill designed to promote stormwater infiltration. Here we see the GeoWeb sections expanded and the workers are just beginning to connect panels side to side with the AtraKeys. This design included a permeable base layer with less than 10% fines for stormwater purposes. The GeoWeb system provides a strong reinforcement layer for the constant heavy loads that the mill infeed area sees daily. Here we see the infill being placed, and a good technique is to limit the drop height to 1 meter or less, about 3 feet, to ensure the empty geocells don't fold over and that they're evenly filled. GeoWeb created a smooth platform that eliminated the rutting and constant maintenance, and both project owners and installers were pleased by the ease and speed of installation thanks to the AtraKey connectors. Here we see a good technique tip with crews working in parallel. On the far left, the placing of the infill by the excavator, while workers expand and connect new sections of GeoWeb, as you see in the right. Far right, we see the roller compaction of the infill. Having a crew with well-defined roles allows this kind of work in parallel and install best practice, and makes for an efficient installation. To ensure everyone knows what to do, take advantage of the contractor training available, including a construction resource package, training guides, videos, webinars, and even in-person or virtual seminars. See prestogeo.com or any of our trusted distributors for more details. This is a good GeoWeb load support project to demonstrate using the GeoWeb as its own site access during construction. This was a project for Duke Energy in Florida to install new transmission towers through the wetlands. Hurricane winds demolished over 100 towers, all of which had to be restored over this extremely soft subgrade, and the saturated sand couldn't support any type of vehicle loading. An enhanced woven geotextile was placed over the subgrade, adding an additional strength layer to the system and allowing water movement without getting clogged by the sandy material. The GeoWeb system was used for access and maintenance roads, as well as pads around the towers. So, as before, the GeoWeb was expanded and held open with temporary stakes, then infilled by pushing via dozer. The GeoWeb panels were filled with a low-quality aggregate that could be easily sourced and transported to the remote locations for this project. Once the panels are filled in, both wheeled and tracked equipment can drive over the systems easily, even when the infill material is sand or other low-quality stone. Again, we see how the GeoWeb panels act as their own access road. Just keep filling up the cells in front of you. No need for additional temporary roadways. This is a great construction time saver and a resource saver. One important advantage for any unpaved surface utilizing GeoWeb stabilization is the use of open graded base cores. Since we do not need fines to achieve compaction for base stability, the system will function like an on-site detention basin, storing water in the void space of the GeoWeb infill. As a rule of thumb, a 3/4 inch or 19 millimeter open graded crushed aggregate has a void space of approximately 35%. So you can calculate how much water you can store to potentially reduce stormwater runoff and ultimately have the ability to reduce stormwater pond volume and land requirements. See any of our in-house engineering team members for help with calculating stormwater requirements for your project. There are many ways to place the infill, and a rock slinger is one of them and allows precise placement for fast, even filling while controlling the height from which the aggregate falls. Buckets with extendable booms can also be helpful, though a push with a dozer or backhoe will work just fine. The GeoWeb 3D system is beneficial under hard pavements, including asphalt, reinforced concrete, and roller compacted concrete, especially in areas with soft subgrades or drainage issues. Now on to some technique tips for those type of installs and for large scale projects. This project for BNSF is a good example of base stabilization with the technique tips of beneficial reuse of on-site materials, staging tables, and site layout, all as key takeaways with this big quantity. This is an auto storage yard for BNSF by the Seattle International Airport. It was a 25-acre site with soft subgrades, and the original design included 2 layers of biaxial geogrids. After bidding, the cost came in higher than the budget allowed. The engineer contacted us and we did a value engineered solution. In the far left of the screen, you see one of the stockpiles of that salvaged material. This beneficial reuse of the material salvaged saves a significant amount of material costs and can speed up your construction time. Here's a best practice pro tip: staging tables, as staging is important for any large project. Here we see the use of staging tables where adjacent panels are connected prior to being expanded and then placed across the prepared subgrade. Each panel has an area of about 270 square feet or 25 square meters, and this contractor is using the tables to connect 3 panels together, providing a total area of over 800 square feet or 75 square meters. The staging tables allow the workers to stand while connecting the panels for a quicker and more ergonomic pre-assembly. The panels are then transferred for installation. Typical installation rates are about 3,000 square feet or 280 square meters per hour with a crew of 3, and work can run parallel with one crew laying out the site, another installing the GeoWeb, and another filling and compacting for your best efficiency. Another technique tip important for large projects is to prep the site layout. This contractor wanted square panels for the entire installation, so they actually surveyed and staked the corners of each GeoWeb panel over the 25-acre site. Once the GeoWeb panels were filled, they just pulled the stakes. Similar to using stretcher frames to open panels to a set distance, this made such a large install go very quickly and efficiently. Here we see the picture of the installation ongoing with a 4-inch wear surface to allow construction access during the installation. Again, using the GeoWeb system as its own access road. At the far left, we see where the contractor stockpiled the on-site sandy soils to mix with crushed aggregate and save construction costs. The expanded and connected GeoWeb mid-screen, and the filling, then compacting as we move to the right. Again, this work in parallel across the site allows for an even more efficient installation process. Here we also see the stakes for the site layout from the site survey. These technique tips made for a very efficient install for such a large project. The dump trucks can back right up to the GeoWeb, dumping the infill material and then spreading via bulldozer. The material supports loading immediately after filling, no cure time needed, serving as its own site access road for construction. And here's the finished surface. So here's a quick recap of some of the technique tips and best practices mentioned for a GeoWeb load support installation. Again, see prestogeo.com for installation guides, videos, case studies, and additional resources such as contractor training resources, or contact any of our team at info@prestogeo.com for more information. Next, we have some installation techniques for the GeoWeb slope protection system for slopes and shorelines. Whether it's a slope adjacent to railways, embankments along a roadway, a mine slope reclamation, geomembrane protection, shoreline revetment, or another type of slope application, there are ways to make that slope protection system's installation safer, easier, and faster. Here's a quick overview of the installation process for a slope system with anchor stakes. First, prepare the subgrade, install a geotextile if it's part of your design, from crest to toe, then anchor the GeoWeb at the crest, noting that horizontal turn at the top. Expand the sections down slope, connecting side to side as possible on the crest, and then throughout the remainder on slope. And continue installing anchors at the frequency recommended by design and at the toe of the slope. The ATRA anchors hold the GeoWeb to slope and penetrate into the ground. And if corrosion resistance is required due to your project conditions, Presto has an HDPE ATRA speed stake designed to work with the GeoWeb and offer higher resistance to extraction than rebar or J-hooks. Again, contact our in-house engineering team, prestogeo.com, and we'll look at your particular project needs and help you come up with the best solution for them. No standard charts or graphs. Once the system is properly anchored, infill, again from top of slope down. And here's an example of a railway slope in Montana with the use of ATRA anchor stakes. Aggregate infill was chosen for both sides of the embankment for erosion control, plus a low maintenance slope cover. This project shows the benefit of material delivery at the top of the slope, greatly reducing the handling and truck traffic in the surrounding areas. When such delivery is possible, it makes for a faster, safer, and easier installation. Here we can see the workers installing the stake anchors to help keep the GeoWeb section in place. And here the panels being filled with crushed aggregate. Again, infilling is done from the top down to prevent panel overstretching. Rock slingers, as shown in the load support section, also work well for this type of top-down infill process. Here's a close-up picture showing the GeoWeb panels were extended under the bridge abutments, and again, filling them from the top. And a picture of the finished slope. Here's another example from a mine slope with ATRA anchor stakes and waste rock as the GeoWeb infill. This project is great to see work in parallel and an ATRAGAD to drive anchors, with one worker measuring and marking for stakes, another placing them for anchorage, and another using a pneumatic hammer with ATRAGAD to drive them. This site also used an on-slope delivery tote for safe, expedient restocking of those anchor stakes. And here with the infill placed and slopes stabilized with GeoWeb geocells. Additional in-field adjustments can be made following a stake pullout test with a fish scale to ensure actual values match the geotech report and the information used in the project evaluations calculations. Again, we provide those manufacturer calculations to match your site conditions and anchorage needs for your particular project. No standard charts or graphs and guesswork. This way, a quick double check and measurement with a fish scale can give you some extra peace of mind for your staked slope protection and ensure that the modeling is replicating those real-world forces. Some slope protection systems are over a geomembrane or other liner that cannot be punctured, are on very steep slopes or over rocky soils. In those cases, a system with tendons and load transfer devices is used instead. So here's a quick overview of that installation process for ATRA tendon clip installations. Prepare the subgrade and install the geotextile as recommended. At the crest, insert tendons through the cell wall eye slots and secure the tendons to the crest anchorage. Only the ATRA tendon clip is specifically designed to fully transfer safely and securely the forces placed upon the geocell. Every accessory and every feature has been designed and tested to specifically work together, so we go from problem to design to construction solution with a system where that modeling replicates real-world forces. Install the ATRA tendon clip load transfer devices as per design and at the crest of the slope, then expand your sections downslope. Connect sections side to side and end to end as possible on the crest and the remainder on slope. And anchor the toe with either an ATRA tendon clip or stakes according to the design. Once the system is properly anchored, infill from top of slope down. And now we'll see that process with a couple of project installations for examples, and we'll point out best practices along the way. This is a vegetated slope project at a solar farm and allows us to show some great step-by-step install pics while pointing out best practices with ATRA tendon clips. The solar site included a sloped area leading to a large detention pond for stormwater management, and GeoWeb helped stabilize that slope and control erosion. Tendons were laid out, measured, and marked per design, then inserted through the eye slots on the slope crest, with sections being built on the flatter ground where it's safer and easier to work. A suspended rod through the tendon spools is a good technique tip that can be helpful when marking and inserting the tendons. For this GeoWeb slope protection system, a PVC pipe was used as a deadman anchor at the crest of the slope, and here's the connection of the tendons to that pipe. Earth anchors at the crest are another option, especially if the site is not conducive to digging an anchor trench, as with this road embankment. From a constructability standpoint, it makes the downturn of the GeoWeb at the crest difficult, so extra care must be taken to prevent undermining of the system from above. The earth anchors may be installed right through the geotextile, as seen here. There are many ways possible to tie off the tendon to the crest anchorage, whether that anchors a deadman, an earth anchor, or some other type of system. The specific knot type is up to the contractor to determine, as long as the knot is secure and permanent. One recommended knot known is the trucker's hitch knot, and is a self-binding knot common for tying loads to secure them to a fixed point. It can be tied anywhere in the standing part of a line and can create high tension lines that can be used to safely secure heavy loads. Here's what that knot looks like. Okay, back to slope stabilization and pre-assembly. The pre-assembled sections, once connected to whichever version you have of the crest anchorage, are then hung over the slope like a curtain and extended down slope. With the GeoWeb system and tendons and anchor tendon clips, you can pre-measure and mark and know the layout for pre-assembly based on project design. Let's look at a project to underscore the value of that pre-assembly and show you some pro tips for how to do it. This tendon GeoWeb slope project highlights the pro tips of that marking and pre-assembly using staging tables for pre-assembly of the GeoWeb after tendon clips and tendons. Ergonomic and efficient. An assembly line with staging tables allows for pre-building the slope protection sections. The pre-assembled panels are marked for location, then taken to install, ready to hang in place on the slope. That pre-assembly means much work is done on the flats instead of slope side, much safer and more efficient for the workers. Here's a quick recap of some of the technique tips and best practices mentioned for GeoWeb slope protection system. For installation guides, videos, case studies, and additional resources, visit us at prestogeo.com or follow up with any from our team at info@prestogeo.com. Our next set of installation techniques will be for the GeoWeb earth retention system. Here are the two different wall options in cross-section. Gravity walls with longer pieces of web at the bottom that get shorter as you go up, and the weight of that infilled GeoWeb provides the retention. Or the GeoWeb with GeoGrid reinforcement. So the GeoGrid provides the retention and GeoWeb functions as a fascia alternative. In either case, the front cell can be filled with topsoil and the back cells or reinforced zone can use any drainable material. The Atra wall key is the major component for a completely integrated earth retention system and is used to connect adjacent GeoWeb retaining wall sections through the material eye slots. The Atra wall key includes an integrated washer at the base of the handle for coverage of the eye slots, frictional barbs for an improved interlock with the GeoWeb sections, and an ergonomic handle with S-shaped contouring for ease of installation. Formulated to withstand weathering and ultraviolet radiation, the Atra wall keys will not corrode or photodegrade, even when exposed to harsh environments. Securing sections with wall keys is faster than using staples or zip ties, requires no tools, and can be completed by one installer with one easy turn. So here's a quick overview of that installation process for the GeoWeb earth retention system. As with other applications, prepare the subgrade and install any geotextiles as recommended by design. The step of expanding the GeoWeb sections is best done with stretcher frames or stretcher bars. Pro tips in their own regards, we'll come back to those in detail in just a few slides. And the interconnection of sections has another pro tip option with the Atra wall key, color matched to your fascia. For vegetated walls, topsoil in the front cell, and any granular drainable material in the back. For a geosynthetic reinforced wall, add the GeoGrid as recommended by design and shown in step 10. For a vegetated wall, either reinforced or gravity, on to step 11. While reinforced walls are not limited in height, It's a good technique tip to use multiple tiers of shorter height walls rather than a single wall tier. This is because the length of the reinforcement may become too great with a single tier. The ratio of wall height to reinforcement length is about 70%. So a 6-meter or 20-foot high wall needs about 4¼ meters or 14 feet of reinforcement grid. And a 40-foot high wall would need about 28 feet of reinforcement. You get the idea. So using shorter tiers or terraces allows you to keep the reinforcement length reasonable while still achieving the overall required height. GeoWeb walls can be vegetated or non-vegetated with concrete or crushed aggregate as the infill. This wall is benched and stepped back, and we see the ability to change the batter angle over a short distance. We'll offer a pro tip for batter angle in just a bit. GeoWeb earth retention systems offer some great benefits beyond just stability. Aesthetics and cost are compelling reasons. Here are some others. GeoWeb also helps reduce urban heat island effects and can help green up your urban areas. GeoWeb walls are environmentally friendly due to their no maintenance vegetation and the ability to capture stormwater runoff. Using local grasses and flowering vegetation will help ensure easy growth and a natural look, and the after wall keys are color matched to the fascia for additional aesthetic benefit. Installation of the GeoWeb wall system is fast, and materials are lightweight and easy to assemble. GeoWeb MSE walls are both less expensive for materials and for labor compared with traditional MSE walls, such as masonry walls or Gabion block walls. Compared to many other wall systems, GeoWeb walls have a lower carbon footprint for manufacturing and transportation, and they can help with green infrastructure and low impact development plans for a project site as well. Contact us at info@prestogeo.com or talk with any of our in-house engineering team to help design a GeoWeb wall for your earth retention needs. One of the most significant benefits of GeoWeb walls is the relative lightweight compared to concrete MSE walls and its ability to tolerate reasonable differential settlement. So building over soft soils or areas where differential settlement is a concern is no problem for GeoWeb walls, as they can handle several inches of differential settlement. This is vital for areas with saturated soils. Here we can see a GeoWeb wall being constructed in close proximity to extremely wet rice fields in Japan. Using the GeoWeb system can help avoid expensive and time-consuming activities such as surcharge loading a site, which often has to happen when differential settlement is a concern. The time required for the surcharge loading may be reduced or even eliminated when using a GeoWeb wall. It also reduces the amount of visual inspection maintenance and repair over the lifetime of the wall structure, since the GeoWeb panels can accommodate much more movement than any masonry wall could. GeoWeb walls perform well in strong seismic areas and with live traffic loading. It's always necessary to consider live and dead loads that the wall will experience during construction and over time. Dead loads can be buildings or the soil slopes above the wall. Live loads are for construction traffic and long-term vehicle traffic if the wall is below a road or driveway. When possible, these loads should be placed away from the edge of the wall or fascia. If not, the design will have to be robust enough to support and withstand the live and the dead loading. Having traffic barriers at the top of the wall will help keep the loads away from the front face of the wall system which can also help with the design. GeoWeb walls work well with integrating traffic barriers and infrastructure, such as the sonotubes and large pipe culvert seen here. There is no loss of structural integrity because of the continuous web connections with the ATRA wall key. GeoWeb sections can be easily trimmed to fit culverts, sonotubes, or other obstructions. Let's get into more tips for fitting and fieldwork. Building a stretcher frame is a definite best practice for geocell retaining walls, and we have plans for wooden ones, ideal for walls with a constant cell size, such as most reinforced walls, or for expandable ones that are better suited for gravity walls that have more cells at the bottom and less cells as the lifts are increased. Check out the installation tab at prestogeo.com to download the full construction resource package or just the stretcher frame plans. While stretcher frames are great for a straight wall, a pro tip is to use stretcher bars for any curved areas. Our installation guides have plans and diagrams for both, and now we'll look at some step-by-step wall builds so you can see them put to use. Most of the examples will show wooden stretcher frames, but remember they can be made out of PVC or other materials and can even be adjustable, like this example. Use what works best for your site's needs. And again, if you're in doubt, contact our team, info@prestogeo.com, and see our case studies and resource guides at prestogeo.com. Now we'll walk through the steps of a GeoWeb earth retention system being built as part of a vegetated stacked channel. Preparing the footing for the GeoWeb wall, and on the right, you see the footing layer of GeoWeb installed with granular infill placed, and we see the stretcher frames and infill process. A pro tip is to have a portable compactor on level with the build and compact as you go. Here are the stretcher frames from another angle. The stretcher frames are placed spikes up, and then the GeoWeb is placed over the stretcher bar. Once the section is open to its optimal size on the frame and GeoWeb are flipped over, making sure the fascia panel faces the proper way. Once the section with frame is in place, infill can be placed and then the stretcher frame lifted away. Here we see the frames lifted away and reloaded, far left, getting ready for the next layer. Don't forget to compact each layer. And the process repeats, going down the line, connecting panels side to side. And working in parallel for an efficient installation. And as one side of the stack channel was completed, onto the other, also using stretcher frames. And here we see the newly constructed GeoWeb walls on either side of the watercourse. And as vegetation begins, the front fascia cells were seeded with a native plant mixture and an aggregate topsoil mix. Notice the slight curve in the wall towards the top of the screen. When your wall has to curve beyond a gentle turn, stretcher bars are a best practice as they'll hold the wall cells open to that optimal expansion while making the consistent curve radius needed. Note the portable compactors to compact the foundation layer. In this slide, we see their wall path transitions from straight to curve, with the stretcher frame used for straight portion and in conjunction with the stretcher bars. The process for stretcher bars is similar to a stretcher frame, only in a curve and no flip needed. See our installation resources, including videos particular to placing stretcher bars and other pro technique tips on our YouTube channel. Many of our earth retention project evaluations will incorporate grid reinforcement and call out specific strength characteristics and spacing. Most geogrids will be uniaxial, primarily for cost purposes. Make sure they're installed in the correct direction and appropriate minimum strength. For uniaxial grids, that means perpendicular to the wall face, since the grid only provides strength in that one direction. Again, talk to any of our team, prestogeo.com or info@prestogeo.com for help with your project needs. The geogrids will need to be pre-tensioned once laid out. Install the grid as far forward as possible without sticking out of the wall face. Do not overlap the grid layers due to low friction angle and slip planes. And again, follow the geogrid manufacturer's guidelines. Most evaluations will also include a non-woven geotextile separation layer placed against the retained soil. Make sure to have the correct overlaps side to side and end to end. And again, follow the geotextile manufacturer's guidelines. Drainage is a very important topic that needs to be addressed with any MSE wall, including the GeoWeb wall system. Hydrostatic pressure buildup and improper drainage behind a wall face is the leading cause of wall failure, no matter the type of wall. The GeoWeb system is better equipped than impervious walls such as concrete block walls because by its nature, it allows for water movement throughout the system. However, even with this, it's crucial that you understand your specific site conditions and ensure that hydrostatic buildup is mitigated. One of the best ways to mitigate that hydrostatic pressure is with a drainage pipe installed behind the GeoWeb panels. This could be a perforated pipe wrapped in geotextile to prevent clogging. This type of drain system is a best practice pro tip you'll want to be sure to include. The drain pipe should daylight in an area that can manage that collected water. The pipe can either come through the front of the wall, like shown here, or it can end at the side of the wall, depending on what works best for your site. It's also important to make sure that wherever that pipe drains is set up such that excessive erosion will not occur at that outfall, which could lead to undermining the wall at that point. This is the most common type of drainage mitigation. The drainage system needs to be designed by the project engineer and can include as many pipes as necessary to ensure that water is properly collected within the wall structure. Using a clean aggregate and other good drainable soils as the infill and backfill can also help you with your drainage concerns. If you know there's a place for the water to flow, such as the groundwater system or a nearby lower elevation creek, allowing the water to drain straight through the GeoWeb wall is an option. The material used in the construction of the wall will have to be sized for the task, so using an aggregate mix with very low fines content can be a good choice. Sandy soil mixes are also good for drainage. You want to avoid using clay or silty soils, which will impede drainage and cause pressure buildup behind your GeoWeb walls. A drainage trench above the wall can help Route surface water away from the wall so the structure does not become oversaturated. Here's another issue to consider along the lines of drainage. If your location is an active channel with flow, that water can be rerouted. And here's a stacked wall channel example. Bypassing the construction area. And here's that channel with the vegetation starting to establish. And then 4 years after the install, invisibly yet reliably protecting. If you prefer or don't want to afford to bypass or reroute that water, it's okay to construct the system in water too. Stepped walls are a bit of an advanced installation, needing some technique and extra planning. Our full installation guide gives examples of calculating offset dimensions for a GeoWeb wall on a stepped base, and you should be sure to coordinate with our in-house engineering team for some additional guidance. Stepped walls can be useful for an interesting wall such as this, where the engineer used 3 different wall batters and multiple stepped areas to make GeoWeb fit the site conditions. We mentioned the drainable fill a few slides back. You may also consider grouting the front cells or filling them with concrete when any high flow conditions are expected, like this highway retention pond. Or a mix of medium, as you see in this project, with aggregate fascia along the pathway and topsoil for vegetation elsewhere. The careful alignment of cells vertically from one lift to another is a good pro tip and worth the extra care. Not only will the wall be more aesthetically pleasing, especially important if it's not vegetated, but the alignment will help prevent potential material loss in the fascia cell that may occur if your cells are misaligned. Here's an example of good cell alignment. And another. And another technique best practice and pro tip is to check your wall batter as you build. Here we see the construction in process with batter check stations along the way. No problem with compaction or around curves. The same setback angle is maintained. Again, notice the cell alignment vertically from one lift to the next in the curved area in the photo on the right, and how the batter checkboards help keep your consistency. Batter checks are a good pro tip to build beautiful walls. And a proper wall batter with slight setback is not only nice looking, it can help ensure good vegetation for your wall. We typically recommend a setback of about 5 centimeters or 2 inches. Here we can see the wall structure is constructed with a slight setback to allow that topsoil fill in the front cells, and the wall can be seeded either by mixing the seeds in the soil before installation or by hydroseeding once your installation is complete. And then this turns into this. To design your own GeoWeb earth retention system, Request a copy of the MSC wall design software from our webpage, prestogeo.com, in the Design tab. Otherwise, you can activate our in-house design team for a free project evaluation and let us do the heavy lifting for you. Here's a quick recap of some of the technique tips and best practices mentioned for the GWeb earth retention system. Again, visit our website for installation guides, videos, case studies, and additional earth retention resources, or contact us at info@prestogeo.com. The following set of installation techniques will be for the GWeb channel protection system. As the install process for channel projects can be similar to many of our slope systems, and as we touched a bit on stacked channels with the GWeb walls, we'll focus on aspects not yet covered, such as hard armor protection and applicable technique tips. The GeoWeb channel system installation steps are similar to the slope install initially, though as you expand your sections downslope, you must note the water flow direction, and the GeoWeb should be towed in at the upstream termination. This is an important technique tip and one you should also do at transition areas if your channel goes from hard armor to competent rock, for example. Key in or tow in at that transition point. Again, talk with our design team for additional details on that specific to your project site needs. Continue installing anchors at the frequency recommended by design. And once the system is properly anchored, infill from top of slope down. If it's a concrete channel armoring install, it may work best to fill the bottom of the channel first and then your side slopes from crest to toe. We trust the GeoWeb system and have the experience and research to back us. Presto did a big series of channel armoring tests at Colorado State University under the direction of Dr. Chris Thornton. CSU is considered one of the top hydraulic research facilities in the world, and their lab has a couple hundred feet of static head, about 80 meters, to achieve extremely high velocities and shear stresses in both their indoor and outdoor test flumes, with impressive results for vegetated, aggregate, and concrete channels. Let's dig in with some technique tips for each, starting with vegetated channels. Here's a technique tip for using the GeoWeb system along channel side slopes. Notice how the panels just cover the sides, not the channel bottom. The GeoWeb panels will allow for vegetation growth up both embankments, which will not normally be underwater. Notice the bright yellow liner below the panels. In this case, using the tendon anchorage system will hold the GeoWeb panels in place without damaging that liner. But even with the liner beneath, vegetation can still grow thanks to the soil held within the cells of the GeoWeb panels. As this stormwater overflow channel becomes flooded during storm events, the side slopes are protected and the channel will do its job. Here's a project near Phoenix, Arizona that can highlight some new technique tips for us and show an aggregate channel example. Heavy runoff from intense storms were leading to erosion and flooding in adjacent subdivisions. Several existing embankments and channel sections failed under 100-year storm events. Here's a pro tip particular to channels. One of the really nice things about GeoWeb is it allows for adjustments. Here we see the GeoWeb cell depth reduced from 8 inches to 4 inches. The second half of the channel from the main inlet was subjected to reduced flow rates and shear stresses. Because of this, less protection was required, so a shallower GeoWeb panel was used, which saved cost and installation time while still meeting performance requirements. A seamless transition was made by connecting a 30V8 to the 30V4, as you see here, only possible thanks to the Attra-Key. Using staples or zip ties would not provide enough strength and the panels would separate over time. The GeoWeb panels are flexible and can be easily cut in field to allow for pipe penetrations as we saw with the sonotubes in the GeoWeb wall portion. And again, no loss of integrity to the system performance. Here we see some drainage pipes from a nearby detention pond, and it's very simple to complete field cuts of the GeoWeb panels and accommodate structures like these, so there are no areas left unprotected. That area right below the drainage weirs should be built more robustly, since this is the area with the highest potential for stone washout due to the turbulence of water coming out of the pipes. The infill was waste rock from a nearby quarry and not the greatest quality, but that's okay. When using GeoWeb, the rock does not have any requirements other than size and that it be angular, so money can be saved on material and hauling costs. The only infill material we recommend avoiding is river rock or rounded rock, since it does not lock up as well and will be scoured away over time. The advantage to GeoWeb aggregate channels is construction equipment can drive on the GeoWeb areas immediately after infilling. So again, you can use the GeoWeb channel as an access road for construction, as you see in the photos here. And here's the installation under typical flow conditions. And you see the technique tip of adding drop structures, and several were designed throughout the channel to reduce velocity before reaching the end of the channel, so the water will be transported to the groundwater system. With the aggregate protection system, there's little to no maintenance required, and since the aggregate is confined, it won't need to be replaced. The channel is large enough to accommodate large storms without overtopping. Outfall areas can be challenging because they typically have high velocities and shear stresses, more so than the channel as a whole, and the water in these areas are turbulent rather than laminar and smooth, which can cause its own set of problems. Using the GeoWeb system can help mitigate these concerns, especially when concrete is used, since turbulent flow and high velocities are not an issue. For concrete channels, another pro tip is to use the GeoWeb as the formwork, having it contour as needed for your outfall structures. The GeoWeb channel system is flexible enough to modify the structure. Here's a technique tip of grouting in large riprap in a rockfall area of a mine closure channel. Or you can add energy dissipators, again, directly to your GeoWeb with concrete infill, and directly as part of your channel design. If you want a vegetated channel but have strong flows, a pro tip is to include surface protection over the panels, such as a TRM or Quar fabric, as you see here. This is intended for short duration events rather than strong continuous flow. If you have high flow or shear stresses for your channel armoring, you may likely be using a concrete infill for your GeoWeb channel, like this mine closure channel in Guatemala. Here we see the technique tip of filling the channel bottom first and then the side slopes. This is to ensure the system stays in place as no stakes are used, but can also facilitate construction as crews can traverse that channel bottom and finish the side slopes. Then for the side slopes, fill from crest to toe. This channel had a drop structure rapids incorporated, and here we see the joining of the rapids to the rest of the GeoWeb channel and a drone view of the rapid structure here. A pro tip for concrete channel infill is to use a concrete boom pump, as you see here, or a line pump if you have an install easily accessed horizontally. Another important consideration and technique tip is to include site access along the channel crest that can support the loading of cement trucks and other heavy equipment. Temporary access mats can help if design constraints will not permit access as part of your design, and can even be placed in the water. Here's a quick recap of some of the technique tips and best practices mentioned for a GeoWeb channel armoring system installation. For installation guides, videos, case studies, and additional resources, visit prestogeo.com. We deliver quality and over 40 years of expertise, guaranteeing each shipment meets or exceeds our specs, so you can deliver certainty and build with materials you can trust. No disclaimers or concerning fine print, and the best quality and service in the industry. Part of our complete solution is our technical assistance. The engineering team here at Presto Geosystems works closely with landscape designers and engineers, offering a free project evaluation service for any roads, embankment, or erosion control project. The form is on our website, prestogeo.com. Fill it out with as much information as you have, including attaching documents such as geotech reports, project site pics, or other info, and it comes directly to us. We've made it fast and easy for you to obtain your PDH certificates. And with our webinar dashboard, you can easily view our library of webinars and download PDH certificates for on-demand webinars completed. Your webinar dashboard will help keep a record of on-demand webinars completed, along with PDHs earned. Please note that certificates for live webinars are managed separately from the on-demand webinar dashboard, so you won't find your certificate from today in there if you joined us live, but you will receive an email from GoToWebinar within the next 2 hours containing a download link to obtain your PDH certificate. In 2 or 3 days, you'll also receive a separate email from Presto Geosystems with more information about accessing the on-demand webinar dashboard and other helpful resources. If you do not receive either of those previously mentioned emails, please check your spam folder and reach out to us at info@prestogeo.com. And that's the presentation. I want to thank you for attending and remind you that you can send questions to us at any time at info@prestogeo.com. Go to prestogeo.com for a wealth of information, and don't forget to view our YouTube videos found by clicking on the YouTube icon in the upper right corner of our webpage. If you have a technique tip that we didn't mention, please let us know. We would love to hear from you. We went a bit over on time today, and I thank you for your patience and the extra time shared with us today. I'll answer your questions next, but if you have questions I don't get to, or a pro tip to share, please respond to that follow-up email. I look forward to hearing from you. And now on to our questions. We'll look at them in order that they arose. All right, the first one regarding slope protection. Do we recommend an upper key in addition to the lower footing? It's going to be installed as hard armoring on a residential lake shoreline. Yes, typically that horizontal turn at the top of a slope will prevent undermining and scour, so that turn in or key in at both crest and toe is important. Next one, can you send the PowerPoint presentation and a link to replay? Absolutely, you'll see a link for that in the follow-up email. Is this CE credited? CE marking on GeoWeb GeoCells, yes. We also have an environmental product declaration and other certifications, including ISO. Let us know what you need for documentation, and we are happy to share that. Next question, when filling the cells, how high above the cell wall do you need to place it? 1 or 2 inches? That depends on the type of application. For a load support, our evaluations will typically call out a wear surface depth. Again, depending on loading, 2 inches is very common. Sometimes it's more. For a channel system, it's typically not going to see such overfill, especially if it's concrete filled, you want it flush with the top of the cells. So it really depends on the type of application. Next question. How effective are geotextiles in stormwater filtration? For example, after stormwater passes the geotextile in permeable pavements. Again, it depends on the type of design of your cross section and which geotextiles are used. We recommend many times a high strength and a high performance woven geotextile, or something that's not going to clog with fines or sand. So again, that will depend on your application and on the site particulars. And which one is common is the next question. Which geotextiles are common will also depend on that application. Next question, how do we know when tendons are recommended? And this person gave an example of a 22-foot long 4-to-1 slope. Such a shallow slope, assuming 4 horizontal to 1 vertical and not vice versa, typically can be staked unless it's something over a geomembrane. Again, we're happy to look at that. We provide a free project evaluation service. So when in doubt, contact our engineering team and we're happy to put something together for your consideration. Next question, how will geocells react to wildfires? The GeoWeb system is actually considered a best practice for fire-prone areas in stabilizing those highly erosive soils. And we have a case study and white paper if you're interested in checking into that, especially as the geocells are buried beneath the topsoil. They can help hold those highly erosive and erodible soils in place and keep vegetation, or not vegetation if aggregates are a better option for your surrounds, keep them in place. Are there examples that this was used on a levee project, and how do we check compaction of the material? Yes, dams, dikes, levees, seawalls, we have case studies for all of them, and there are multiple ways to check compaction. We usually recommend to a certain, like 95% Proctor, but again, can work with you. Check out our installation materials at prestogeo.com and you'll see some technique tips there. Next question, what is the minimum setback of the guard rail behind the face of the wall? We want to keep that live loading away from the fascia as much as possible. A lot of it will depend on your site parameters and requirements. So again, we're happy to work with you and go through an evaluation for your specific site needs. All right, next question. What if a utility infrastructure like a service line, lateral, or storm outlet needs to extend through the GeoWeb material? Have contractors had success in extending infrastructure through an already constructed and connected geocell system? Yes, and we have some guidelines that we can share depending on what you're inserting through there. Again, it's very easy to cut and can work around most type of obstructions. And again, I thank you all for your time and patience today. We're about 15 minutes over our allotted time, so we're going to end it there. And if you have a question or pro tip that we didn't get to today, sorry we ran out of time, please do follow back with us, info@prestogeo.com, or respond to that forthcoming follow-up email and we look forward to working with you on your project's solution. Thank you so much. Be well. Bye-bye.